There we go. All right, look at that nice pretty picture I put on there. Isn't that nice? All right, so let's take a look at this. It says, we're still in 13.1, if you can believe it. It's been, a week at least? Maybe a week and a half that we've done this. But we got to get to it. Oh my gosh, I put angle of elevation and elevation. It's not what I wanted. Let's try this again. Depression. Oh, that sounds so sad, doesn't it? But it's not that bad. Let me change this. Then I'll be ready to go. I'm not going to start recording again. We'll just leave all that in there. All right, so let's take a look. This really right here is not really angle of elevation, angle of depression. We're going to get to that in the next one. But I just wanted to show you why we use this stuff. You hear me all the time, complaining on Facebook where people put stuff, I never use this stuff, blah, 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 And, I've given you explanations that you use it, you use it to think in your brain and all that kind of stuff. But this is a situation where you can use it. Oh, I just thought of this story. My dad told me this story. And he was a science teacher. He was a chemistry and physics teacher for years and years. He taught a lot of just regular science stuff too. A few math classes here and there, but mostly he was chemistry and physics. But he said when he was in college, all right, he saw, I think it was a bird on top of a tree, and he was with a couple friends, and he was taking physics classes and stuff like that. And somebody said, I wonder how tall that tree is, right? Well, you're not going to shimmy up the tree, drop down a tape measure, and figure out how tall it is, right? So what he did, and his friends that were with him, this is in West Virginia, they didn't have a whole lot to do, so this is what they did. They actually walked out to where the tree was from their dorm room. He did this from his dorm room, okay? So from his dorm room, he walked out so they could basically measure, that width. And you could measure an angle. So the tree went straight up, so it made a right angle to the ground. So it was a right triangle, basically. And they actually did trig to figure out approximately how tall the tree was. Isn't that pretty interesting? He did that when he was in college. And so he actually used it, right? And they were probably studying this stuff, in his classes, and that's probably why he thought of doing that, or he and his friends thought of doing that. But I always remember my dad telling me that, and I thought that was pretty cool. I have another story for another time, maybe if I ever teach a physics class. Well, I'll tell you now. There's a... we went to a camp. It was my other school. We went to this camp for a week. It was this Christian camp, and they had this big swing. You ever go to Great Adventure and you see that big old giant swing, right? You usually have to pay extra for it. And they strap you up, in this thing, and they take you to the top, and then you pull the thing, and then you swing. Woo! And you go back and forth, back and forth. You ever see that? So in physics, who takes physics? Anybody take physics in here? Okay. Did you learn the equation for a pendulum? Were you awake that day? Anyway, there's an equation for a pendulum, and all you have to know is the time that it takes for one full rotation of the pendulum or one revolution of the pendulum, okay? And you can figure out how tall the structure is. So I was with my class. I was a teacher at the time, so I had a couple kids that were in my physics class, and I was like, oh, this is perfect. Everybody listen, this is a good story. So I said, let's time, okay, one full it's called the period, but one full revolution. Let's time it and see how long it takes, right? Once they drop. So we timed it, and then I know it's kind of dorky, but we sat there while people were swinging on this swing and like screaming their lungs out. We're trying to figure out how tall the structure is. We just put it in our little formula, and then we figured out what it was. We converted it to feet and all this stuff, and we asked the person there, "Hey, how tall is this swing?" And we were only off by like a couple inches just by timing, how long it took for that pendulum to go. So I thought that was pretty cool. So do people use math? Yes, they do. Okay. Does everybody? No, of course not. But people do this all the time. I mean, all the stuff that we have in this world, your computers, your car, the buildings that we're in, everything that we're in is due to math. Okay, and physics, of course, and chemistry and everything else, all these things. Is everybody going to do that? Is everybody going to figure out the structural integrity of a building and all that kind of stuff? No, not everybody's going to do it, but some people are. And that's why we learn this stuff, okay? We learn this stuff because you have no idea what you're going to do later in life. And you could use this stuff, and it could be very, very helpful to you. All right, enough of that. Let's do this. Let's read it, and they drew a picture for you. And but what I'm going to give you a worksheet today that are word problems. And I know you hate word problems, but they're not as bad as what the word problems you've had in the past, probably. Okay, so let's take a look at this. Let's see how we can use trig to figure out like how wide this river is. Now, obviously, it's going to be difficult, right, for us to take a tape measure, somebody swim across to the other side, hold the other tape measure, the other end of the tape measure, and figure out how wide the river is. Would you agree with that? Yes? Anybody still here with me? I'm giving you good stuff, man. This is gold. This stuff is gold. You should take this in, internalize it, all right? So watch. Across the river right here, it'd be very difficult to measure it yourself. Yeah? I mean, you could throw a rope across it, maybe have somebody hold one end, measure the rope. You could do that, I guess, but it would be really tough. But what you could do is this. You could pick out a point right here, walk a certain distance. Now, finding the angle might be a little tough, but there are devices that you could have. I don't know if there's an app or not. There could be possibly an app that you could find the angle between two things. I don't know. I haven't looked for that, but there could be. And then that's all you needed to know. Okay, you just need to know an angle that it makes to another point over here, make it a right triangle, find this distance. And you could easily find the distance along shore, right? If you take a pretty wide step, that's usually around 3 feet, depending on how long your legs are, obviously. But, you know, if you take a step, you could step pretty easily around 3 feet. So you could figure out what that length is right there. And if you were able to figure out that angle, then you can find the length from one point of the river to the other side of the river. And you can find out how wide that river is. And that's what they're doing right here. It says, in order to construct a bridge across the river, the width of the river at the location must be determined. So they're going to make a bridge. They got to figure out how long this river is or how wide the river is. Suppose a stake is planted on one side of the river directly across from a second stake on the opposite side. Does that make sense? Put a stake here, or you can just mark a spot, right? Mark a spot visually. And then make sure that it's directly across from it. It's 90 degrees. Make a stake right there, so that's your width. And it says at a distance of 50 meters to the left of the stake, so you walk 50 meters, boom, 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 you're at 50 meters, and you can measure that. If you have a tape measure or something like that, you could measure a certain distance. It doesn't have to be 50. It could be anything. But then you figure out that angle. That's the toughest part, okay? So you figure out what this angle is right here, and then you can find this width, and that's what they're doing. An angle of 82 is measured between the two stakes, find the width of the river. So let's do this. I just copied and pasted this thing. That's not really part of the question, but let's figure this out. Let's do that. So what are we going to do? Well, we're using this angle, right? We've got a right triangle here, okay, because this is directly across from it, and this is perpendicular to it. Okay, you got to make sure you do all that when you measure this stuff. And this is 50. How would we find W? Well, we're using this angle. So what do we know? What are we trying to find? Well, we're trying to find the W. What is the W to this 82 degrees? It's opposite. What is this 50 to the 82 degrees? It's adjacent. Which one uses opposite and adjacent? The tangent. That's right. You're getting good at this now, right? Okay. Does anybody actually do this? Put OA in there and then figure out which one is your thing? Okay. I don't know. I just started doing it this year. But there you go. All right. So use the tangent. So let's do this. So we take the tangent of 82 degrees equals opposite over adjacent. So it's W over 50. Solve for W. That's easy because W is already on top. Multiply both sides by 50. And so there it is right there. That is the width. But what do we do with that? This is not a special triangle this time, is it? All right, so what do we do with this? Put it where? Don't say anything bad. Put it in a what? Okay, I was just making sure that that's away from it. Put it in a calculator, right? Anybody here today? For what? All right, so let's do this. Let's clear this, and let's put it in here. So in this calculator, you hit 50. Oh, thank you very much. I did forget. At least somebody's taking care of me here. All right, so it's in degrees. So let's clear it again. So let's go 50. 50 tangent. So on this calculator, you just put it in exactly the way it looks. If you have a regular scientific calculator, one of those smaller ones, what would you do? You'd put I would do this. If you had a regular scientific calculator, you know what I mean, like a TI-30 or whatever they are, I would put 82, then hit tangent, and then it'll give you a decimal, and then times 50, hit equals, and then you should get this number right there, okay? What is that? 355. Oops. Oh, what am I doing? There we go. 355. It's, do they say this is in feet? Oh, it's meters. Okay, so meters. So the width of the river is 355 meters. There you go. With a couple fairly easy measurements, all right? You got to measure the 50, you got to measure the 82 degrees. That was fairly easy if you have the right, stuff. And that, a lot of people could probably do that. If you're out in the middle of the woods and you got nothing on you, it might be kind of difficult. But if you go out, you're an engineer, you need to build a bridge, you're going to have stuff that can measure an angle and measure this 50 very easily, right? And you can figure out, oh, it's 355 meters. And now you know how much stuff to order and all that kind of thing, all right? So there you go. Enough of that. We go to that? That was easy. Yeah, just simple little trig. Now let's do, actually I got to come over here and grab it. Grab this, copy it. Let's do the angle of elevation, angle of depression, but let me do something first before we do that. So let's say, I'm going to try to draw my own little picture here. You're on top of a building, okay? That's a building, and this is you. Boom, boom, boom. There you go, all right? So somebody on the top of a building, all right? And then I'm going to do this. There's the ground. Everybody with me? And then I see something on the ground right there. Now, what I'm going to do is this. This is a line of sight. Actually, we're just going to take it from the top of the building just to make it a little bit easier for you. Okay, so let's say you're looking down. So from the top of the building, you're looking at that object down on the ground. You with me on that? Okay. They're going to give you a thing that says, they're going to say, well, his angle of elevation is, or they're going to say his angle of depression is. If you're on top, we're actually looking for the angle of depression. Let me show you what that is. Let me make this a line. So what I'm going to do, from the top of the building, I'm just going to draw a horizontal line. Now, I don't know if you remember or not. Oops, let's do this. Let's change this back to white. There we go. I don't know if you remember or not. Tell me something about that blue line and that white line right there. They're both horizontal, so they must be what to each other? Think geometry. Give me a good geometry word. Parallel, that's right. They must be parallel. All right, so this and this are parallel. Do you remember that from geometry, putting the arrows there? All right. Hale, you good with this? All right, let's pay attention. So watch, you got two parallel lines. Does anybody remember from geometry when you have this diagonal that goes through here? It's cut by starts with a T. I don't know if you remember it. It's a transversal. Do you remember that? Two parallel lines cut by transversal. Your geometry teacher probably said that over and over again. Two parallel lines cut by transversal. Do you remember what's true about it? The alternate interior angles are equal. Remember that? So watch this. Look at this angle right there, and look at this angle right here. What must be true about those two angles? They must be equal to each other. They must be exactly the same. Now, this angle right here, we call the angle of depression. It's not because it's all sad. It's because depress means you go down, right? That's probably why they call it depression, because you feel down, right? So depression goes down. So it goes from the horizontal and it goes down. You with me on that? That's the angle of depression. What do you think we're going to call this one right here? No, I gave you the title of this lesson, and it's, what is it? Elevation. Anybody write that down on their thing, what the name of this lesson was? So this angle right here is the angle of elevation. Am I boring you, Kylie? No. So the angle of elevation right here. Now, tell me something about the angle of depression and the angle of elevation. They must be, we already said it, they must be equal to each other, all right? So you'll see some books and they'll say the angle of depression equals the angle of elevation. But this is why. This is why those angles equal each other. So sometimes they're going to give you the angle of depression, but you need to make a triangle out of it. So we'll put the problem on here in a second, so I won't put any numbers in right now. But sometimes they say the angle of depression is 23 degrees. And if you need to draw it, you need to draw a triangle. So this right here, I'm just making that up, is 23 degrees. But that's not really part of your triangle, is it? Do you see your triangle? This is your one side, right? There's your right angle. There's your one side. There's your other side. Here's your hypotenuse. That 23 degrees is not really inside the triangle. But if that's the angle of depression, we could say that the angle of elevation is what? 23 degrees. So sometimes they'll give you the angle of depression, but you need to find the angle of elevation, all right, because that's the angle that's in the triangle. What? Just wait. I'm in the middle of talking.
Oh, never mind.
No, if you have a question, you can answer a real question.
All right, so basically, if the angle of depression and angle of
elevation,
if they're on a parallel,
they'll always be parallel, because these lines will always be parallel because the angle of depression is always from the horizontal down to the line of sight, basically. The angle of elevation is from a horizontal, but it's the lower horizontal. It's still horizontal, right? To what? To the line of sight, okay? So if you're up top looking down, the person down the bottom looking up is looking at the same exact angle.
All right, so that means the angle will be parallel to each other. The angles are going to get the same, right?
Their angles are going to be the same, yes. The angles are going to be the same, and the whole reasoning is because of geometry. Parallel lines cut by transversal, alternate interior angles are equal. You probably thought you'd never use that in your life after you learned that in geometry, but now you see where it comes into play, all right? It's really important. That's why math always builds on itself, okay? Everybody with me on that? So let's do an example and we'll be finished. That was easy today, wasn't it? Ah, look at that. So let's take a look. They give you a picture, but I'm going to give you a worksheet today. It's not going to have any pictures. So what you're going to have to do is take the words and you're going to have to draw a picture to it. It doesn't have to be all that fancy with the snow and the ice and the skier and all that kind of stuff. All you got to do is just draw a triangle. Okay, that's your picture. Everybody with me? So let's read it. It says an aerial run in Snowbird, Utah it's skiing, okay, has an angle of elevation of 20.2 degrees. So if I was going to draw this, now I see the picture right here. I can't unsee it. But if I was going to draw this, angle of elevation is 20.2 degrees. So this is what I would do. Angle of elevation goes from the horizontal up, right? So I would draw one here. Whoops. Let's do this. Okay. Let's do this. Oops. Got to figure out the best way to do this. Here we go. And let's do this. All right, so it says the angle of elevation is 20.2 degrees. That's 20.2 degrees. How do I know that's my angle of elevation? Because it's from the horizontal up. Everybody got it? That's the angle of elevation. Does that mean that this angle right here is 22 degrees? No. It means if you drew a horizontal there, that means this angle is 20.2 degrees. But that's not really what we care about. Its vertical drop is 2,900 feet. Which one of these things in the triangle is the vertical drop? It's not this one. That doesn't go vertical, does it? Okay, that's at a slant. This one is horizontal. This is your vertical drop at what? 2,900 feet. All I'm doing is redrawing this, but I'm doing this. This is what yours should look like, okay? Its vertical drop is 2,900 feet. Estimate the length of this run. Which one of these, this one or this one, is the length of the run? Well, they're not skiing along the horizontal here, are they? Where are they skiing? They're skiing down this. So this is what you're trying to solve for. They used L. You could put H for hypotenuse if you wanted to. So let's just set it up, and the bell's going to ring in a minute, so we'll pretty much be good. If you want to find this, you use the angle. What two sides do you know now? We'll call it L for length since that's what they called it. Use this angle. What is this side to this angle? This is opposite. What is this side? Hypotenuse. Which trig function uses opposite and hypotenuse? The sine does. So how do we set it up? we go the sine of 20.2 degrees equals the opposite, which is 2900, over the hypotenuse, which is L. Not as easy as the last one we just did, but we've done this before. L is on the bottom. Where do we want it? On the top. So we take the, you should be able to do this like in one step. Okay, watch real quick. L equals 2900 over what? The sine of 20.2 degrees. Throw that in your calculator, whatever that is. I'll let you do that on your own. Okay, let me stop the recording and then we'll go. And I'll give you a worksheet. Don't leave without a worksheet. Okay.